Good afternoon and welcome everybody to SCAIME Web Conference 2021, and today especially our presentation whose subject is Industrial Ethernet and SCAIME tools for eNod4 integration. For those who don't know me or don't recognize me because of the mask, my name is Christophe Ourdouillet. I'm Business Development Manager at SCAIME, and I'm sitting here together with my colleague Olivier Legendre, who is our product manager for the weighing range and the weighing applications. So Olivier,
hello everybody.
Olivier will be the main presenter for this slideshow, and I will be the moderator. Just to make things clear about the conduct of this session and the organization, the slideshow itself will last more or less 40 minutes, followed by a question and answer session of plus or minus 10 minutes. As the direct interventions during the slideshow are not permitted, I invite you to use the Q&R icon at the bottom of your screen to send under written form your questions that will be answered after the slideshow. So the purpose of this presentation is to shed a light on the tools developed by SCAIME for the integration of the eNod4 in industrial Ethernet architecture. So that goes along with some theoretical reminders about industrial Ethernet, which I'm sure you will find useful. I hope you will enjoy the presentation and find it at least instructive. So I leave the mic to my colleague Olivier to start the slideshow.
Thank you, Christophe. This presentation will be more a mix of theoretical basics about Ethernet, industrial Ethernet, and also some figures about the industrial Ethernet market and the tools we could provide with our eNod4 weighing modules with Ethernet connectivity, and the tool for integration inside automation architectures. So to start, some figures about the place of industrial Ethernet inside the market, the PLC market. And so now industrial Ethernet as a connectivity is more and more popular in the manufacturing world. And for the first time, the field bus, the old field bus, decline in terms of new installation, new nodes, new installed node. So you can find minus 5% in previous year for the field bus. In the opposite, the Ethernet installations grew a lot by 20% in the previous year. And now Ethernet connectivity represents more or less 60% of the new installations for manufacturing control.
So we have to be there on this market.
Yes, we have to be there for the market of communication, of industrial communications. So we can note the main Ethernet protocols, like Ethernet IP is the first one with 50% of the market, followed by Profinet. Here it's mainly for plant engineering and for machine engineering and motion control. You have EtherCAT, it's the first one, followed by PowerLink. Just a word about Modubus-TCP, which was the first industrial Ethernet networks. And due to low performance, we will see after, it represents now only 4% of the new installations.
Mm-hmm.
So we will start with some basics about Ethernet and industrial Ethernet, and we can speak a little bit about what is similar and what is different about the characteristic and benefits. So to start, what is Ethernet? Ethernet is not only cables to connect devices, but is a complete LAN, local area network technology, created in 1970 by Xerox, and now is completely open and standardized. So Ethernet is a standard covering the physical layers, the cables, but also the data link and the media access control, the access control to the different device connected to the network. And why Ethernet is popular? Because it offers a very, very good balance between speed, cost, and it's very easy to install and cost effective. So last point, Ethernet have not to be confused with Wi-Fi, because Wi-Fi is a wireless network. Ethernet always use cables to connect computer and devices. It's not a wireless network, is a cable network. So some other important basics about Ethernet. You have different variants of the physical layer of Ethernet. Here it's some example. It's not exhaustive list, but we can have, depending of the type of cables. For example, you have a D base T. It's twisted pairs, and with this type of physical layer, you can achieve a data rate of 10 megabytes. Also with electrical cable, but using a double twist pair, we can go up to gigabyte per seconds, and you can go up to the red by using, for example, fiber optics. Mm-hmm. So here it's for the physical layers. About the data exchange, it's very important to understand the basics of data exchange of Ethernet. On Ethernet, all the computer and devices are connected on the same line, and they use a specific communication protocol called CSMS-CD. It's a carrier sense multiplexes with collision detect. What is the meaning of that? The meaning is, with this protocol, any machine can communicate on the same line. They just detect if a communication is free. If the network is free, any computer can have access to the networks. So, unfortunately, if two machines transmit at the same time, at this time they have a collisions. Mm-hmm. And to solve the collisions, the two machines interrupt the communications, wait for a random delay, and retransmit. So, because of this behavior in communications, standard Ethernet is not deterministic, because response time depends on collision occurrences. If you have, if the bandwidth is low, you have a high level of collision occurrence, and you have a low response time.
So any collision means a delay in the transmission of the information.
Delay because you have to retransmit again.
Again, and wait availability before retransmitting.
Yes, and the time is a random time, and so it's not deterministic. And is the main. It was the main issue to introduce standard Ethernet in the industrial manufacturing world. So one of the first hardware tools help to use Ethernet in the industrial world is the use of switches, because the switches allow of each exchange take place without collisions, but with increased network bandwidth. Is mainly what is used at the beginning with Modubus-TCP, for example. So what is the difference with industrial Ethernet? Industrial Ethernet is Ethernet applied to industrial use, but which require determinism. Because why? Because industrial environment need data to be sent and received at specific times. We cannot wait for collision and we send some data. For example, if you need to manage a butter filling plant using industrial Ethernet, you need all the command arrive at the good at the right time.
We know that the bottle filling applications are very demanding in terms of speed and accuracy of transmission, and it's not really compatible with collisions and delays, indeed.
So to achieve this determinism of industrial Ethernet, the manufacturer of PLC developed specific protocols in conjunction with a standard TCP/IP transmission. We will see just after for all the industrial Ethernet protocol, Profinet, Ethernet IP, EtherCAT. You will have a part of the protocol that use a standard TCP/IP network, but you have also a second part used for real-time exchange. And we will see different solutions that found the different manufacturer with Profinet, Ethernet IP, EtherCAT, to go to the determinism. And this will determine the performance, the difference of performance of the different protocols.
So on the same standard, each manufacturer has its own solution and recipe to address the industrial Ethernet. So
we come back to the market and to see what is the solutions they originally developed by PLC manufacturer, even if now all the main industrial standard Ethernet are open and managed by associations. At the beginning, this protocol was developed by PLC manufacturers. So the first one, we will start with Siemens that use Profinet. Profinet for the plant engineering and also for very time sensitive applications for machine or for motion control. They also use Profinet because Profinet, you have different type of Profinet we will see after. We have Profinet real-time RT or called IO for the the plant manufacturing or middle time-sensitive applications, and for high time-sensitive application like motion control, they use Profinet IRT.
Okay.
So for Schneider Electric, at the beginning, they introduce Modubus-TCP IP, but as we have seen just before, it's less and less used, and now they promote more Ethernet IP. And for the very high-speed applications, the time-sensitive applications, they use Circos 3.
For motion control?
For motion control, mainly, and for robotics, for robots. The third main actors is Rockwell Automations that use also Ethernet IP for plant engineering and also for machine control. So I also note two other manufacturers. The first one is BNR that created PowerLink, and PowerLink is high-speed Ethernet used mainly for packaging applications, because it's the specialty of BNR, and motion control.
Okay.
And the last one is bake-off with EtherCAT, and EtherCAT is also a very high-speed, provide very high-speed communications for high-speed motion controls. So a small description of what we can propose as a weighing controller is eNod4 is our transmitter, weighing transmitter, available with Ethernet connectivity. This Ethernet connectivity offers two Ethernet ports with integrated switch and hub. So embedded web server that allow to make the setting or to have a remote access, and also provide the capability for a firmware update, for example, or save and remote configurations. About industrial Ethernet network, we offer different versions of protocols. Modubus-TCP, Ethernet IP, Profinet IO, and EtherCAT.
So eNod4 is a family of products with different versions for different types of functionality, from a standard weighing application to dosing, check weighing, etc. Each of those versions is available with those protocols.
Exactly. You can
you have the choice.
You can application for dosing, application for check weighing, with the choice of communications you need.
Okay.
So what is the different approach for industrial Ethernet? Depending of the manufacturer, the solutions you have mainly three types of solutions to improve the determinism of Ethernet. The first solutions was adopted by Modubus-TCP and Ethernet IP is to use the standard physical layer of Ethernet, but also a standard first level of first layer of communication, TCP IP, plus very important UDP. We will see after what is UDP, and they just add an application protocol layer specific for real-time exchange. For standard exchange, HTTP, for example, for internet access, FTP for file exchange, or SMTP for messaging, they use standard TCP/IP. But for real-time exchange, they use specific applications in conjunction, mainly with UDP transport layers. Here, it's the first approach that provide the lower response time. If to increase the speed and the determinism of the applications, here it's the solution in the middle of a slide is a solution for Profinet IO or PowerLink. It's to keep TCP/IP protocol only for low speed communication for internet, HTTP, or file with FTP. All the real-time protocol don't use the TCP or UDP IP part of Ethernet, but only use the physical and network access layer, the low level of Ethernet standard. All the real-time exchange are made by a specific software. And the last one is if you also shorten the response time to have very high-speed communications, you could the manufacturer modify the physical layer of Ethernet. It's the case for Profinet IRT and EtherCAT, and also for Circus-free.
Okay. So they don't rely on the physical layer. Yes. They even modify that basic layer.
Exactly. You always have a part of standard with TCP/IP and standard physical, but only for standard low-speed communications with using generally a very low part of the bandwidth.
Okay.
So we can go to the detail of performance of the different industrial Ethernet protocol. The first one is Modubus-TCP. In Modubus-TCP, as the name indicates, they use a standard TCP/IP protocol with just adding an application layer at the top of the protocols. So Modbus originally was defined by Schneider Electric, but it's supported by an association, Modbus IDA. Is based on the standard TCP/IP, and with an add-on with RTPS. It's an add-on using UDP. The response time is 20 milliseconds. It's not really.
Rather low.
Yes, it's not
high performance.
No, it's not high performance, and the main important things. Synchronization is not possible, so it's not possible to make motion control, for example, with Modbus. It's totally impossible. Just a word about UDP. UDP, it's a specific comparing with TCP. UDP, it's a standard of Ethernet, but without connections, without connections, the connection is not controlled. So you have more speed, it's faster than TCP, but you don't have any control of communication, and so the control of lost data have to be taken charge by the applications, layer, Modbus, for example, or in the second case by Ethernet IP. So we can go to Ethernet IP, is defined originally by Rockwell, but now is supported by ODVAs and associations, and used by lots of PLC manufacturers now, and also by Schneider Electric.
Mm-hmm. Okay.
It's also based on TCP IP layers, standard layers, and they use TCP for all the standard communication for internet or messagings, and for all the real-time exchange they use UDP in combination with CIP applications that provide functionality like priority management, synchronizations that is possible with Ethernet IP, and you can see the response time is 5 to 10 milliseconds for Ethernet IP.
So already twice better than Modubus-TCP.
Yes, Modbus, and it's enough for lots of applications like in the process control for plant management, machine management.
Mm-hmm. Okay.
And the capability of synchronization is possible, so you can also make some motion control with Ethernet IP. So what we provide to help automation engineer to integrate our eNod4 inside this architecture. The first, in fact, we provide software tools. The best software tools we name PLCLib. What is PLCLib? PLCLibs are library of function blocks. Mm-hmm. Function blocks that automation engineer can integrate inside the PLC software environment. In this example here is the software engine environment is Studio 5000 Logics Designer. Is the software environment for Rockwell. And with our library, function block library, you can easily integrate our module in this environment to make the applications.
Yeah, because the developer can modify
the
source code,
modify or not.
Yes, or not, if necessary.
If necessary, can modify, because we provide for all this library, we provide the source code. It's free of charge, and this source code is modifiable, sorry, by the developers. So if we enter in the detail of these function blocks, for all the PLCLib for eNod4, we provide 5 function blocks. The first function blocks is the main blocks, allow to read, write measurement of from EtherCAT. Also, you can read the status of measurement, and also these blocks allow to make command for operation. For example, a tar command or zero command. Other important block now is more for settings is calibration blocks, and these blocks take care of a complete management of physical or theoretical calibration process. Mm-hmm. Very important for a weighing system, for a weighing system, or for an automation engineer that are not because it's a very specific operations. Mm-hmm. Not very
somebody who is not familiar
yes,
with the technology of weighing can easily use this block to manage and make the calibrations.
Another blocks, it's a backup block, and these blocks manage a complete configuration backup and restore. You have also the advantage to list all the parameters available on eNod4. Another blocks very specific to our activity in weighing is a legal methodology block that allow to read and write the data storage device that store the weight.
So even if you're not in a metrology or trade-approved application, it's always useful to have in memory the registering of the data if necessary for quality control, for instance.
And the last block is about the filtering. And with this block, you can make a complete setting of filtering inside eNod4.
Filtering, which is the main one of the main advantages of eNod4 technical specification is the variety and the performance of the filterings.
With all these function blocks, the automation engineer have a complete set of examples of how to manage our device in the environment, in its environment, software environment. Okay. So as we are partners,
technology partner
of Schneider Electric, we provide this type of function blocks for Ethernet IP, eNod4 in Ethernet IP for the software environment of Schneider Electric for plant and machine is EcoStructure Control Expert for plant and EcoStructure Machine Expert for machines.
Machine Expert, well, the function blocks for machine, which are quite recent. I think they were added only beginning of this year, January or something.
Yes, in January of this year. So we can go to after Modbus and Ethernet IP. We can move to the Siemens world with Profinet. Profinet was defined originally by Siemens, supported now by an association. It's Profibus International Associations, so it's open. And Profinet use 3 communication services. The first one is TCP IP, is used for non-deterministic functions, such as parameterizations, but also to access to internet in HTTP, for messaging in SMTP, for example. And for the real time, you could have 2 different types of Profinet. For response time requested from 1 millisecond to 10 milliseconds, you can use Profinet IO with a special channel used for deterministic functions. You don't use TCP IP, but you use a specific application, but with standard physical layer. Is on the left on the slide. For if you need higher speed higher response time than 1 milliseconds, Profinet use the possibility to with Profinet IRT to to have a response time up to 0.2 milliseconds, mainly for motion control, for robotics. And at these times, as you can see at the right of the slide, this is made by a specific physical layer of Ethernet.
Okay.
And so we provide also for Siemens, we provide a library, a function block library, the same blocks, main blocks, backup, calibrations, legal for trade, for eNod4 in Profinet, and it's available for Siemens TA portal. Is the software environment of Siemens in version 15 and version 15.1 now. And the last industrial Ethernet network we offer with eNod4 is EtherCAT. For these protocols, for this industrial network, we don't provide PLCLib function blocks yet.
Okay.
The environment is TwinCAT, and we don't provide now this type of library. It's not available now. So EtherCAT was defined originally by Bekoff and supported by an associations, also EtherCAT Technology Group. And EtherCAT is based on a proprietary physical layer to offer a very high speed, mainly for robotics and for high-speed motion controls, with a very low response time, up to 30 microseconds, with a synchronizations lower than 0. microseconds.
So we are far from the 20 milliseconds of
in fact, they define a complete different protocols that also integrate the TCP, standard TCP. Inside, they integrate the standard TCP IP for internet access, for file exchange, for low-speed communications. But this part of standard Ethernet use only 1% of the bandwidth is reserved for this type of communications. All the other bandwidth is reserved for real-time applications.
Okay.
So, as you've seen, it's more or less technical, and we are aware in SCAIME that this in SCAIME that often the customer and the software and the automation engineer need some support to integrate the PLCLib function block inside the environment, or to integrate our modules inside the environment. And so we have in SCAIME a technical support. As we are technical partner of Schneider Electric, our support is we can go more in detail with Schneider Electric. We are equipped with complete architecture for Schneider, for machine or for plant. We have here all the PLC necessary to make simulations and to help the customer. But we are also able to help automation engineering for other, perhaps not in detail, but at the first level, to help automation engineering for PLCLib use for Siemens or for Rockwells. And also, if a customer have some question for integrations of eNod4 in EtherCAT, it's always possible. All these tools are developed by SCAIME, and we have the skills to help the automation engineer.
Yeah, the developers and the users. Okay, thank you very much, Olivier, for this challenging presentation. It's true that we wanted to focus on this point because the development of the PLCLib library is something that is very helpful and goes in conjunction with the wish, the SCAIME wish to be more present on this segment of the market, offering complete solution. This complete solution is not only the hardware, the load cells, the transmitters, but also the function blocks that will help our customers to accommodate, integrate our weighing chain into an architecture. And as if we come back to your chart pie with the different protocols present on the market, today we have solutions for more than 50% of what is sold today on the market, between Profinet, Ethernet IP, and Modbus. So there is
EtherCAT also,
and EtherCAT, yes.
For high-speed
so
applications.
this is a complete solution that we are able to propose today. The function blocks, as Olivier mentioned, but I remind you that they are available in the download sections of SCAIME website, free of charge, can be downloaded there. And also the support team of several engineers who are familiar with the PLC issues are there to help you and back you up. So you will find there also on our website their address, their email address, so that you can send them some questions. Talking about question, I'm asking my colleague who is in charge of the technical running of this session. Yvan, do you have questions from our audience?
Yes, we have one question. Do you have function blocks for M240 with so machine?
Yes, exactly. We have this function block is the function block for EcoStructure Machine Expert. The name has changed, but the library is operational for so machines.
So something that we can definitely answer positively.
Well, we have another question. Some programmers download function blocks for eNod4T, but they have an eNod4B or else, and struggle to use the function-specific weighing application. Is there any function block for some basic function like read totalized weight, write target flow rate for eNod4B?
Not yet. As you've seen in those presentations, we have developed now the function for eNod4T. For us, it was a great work because it's very time consuming to make all these libraries. And so we have to part our development time between the development of function blocks and the development of our product. And so in the future, we are thinking now, yes, to provide a function block for applications, in particular for B or for F version, for BET, where the the philosophy of a product is a little bit different because it's continuous weighing, it's not static weighing. And so you have very different functionalities. And so, yes, I think in the future, we are in mind, we are in our roadmap to provide this type of function block, but not in the next week.
But we are aware of this kind of demand, which is coming from the market for a lot of the dedicated functionalities of eNod. But it's a brick by brick construction. Yes. We have started with some PLCLib. We started with Ethernet IP, and then 2 other protocols, etc. Now for the machine, and there will be some other developments, but okay, one after the other. But it is something that demand that we are fully aware of, indeed.
No more questions.
Okay. All right. Well, thank you very much, everybody. I hope you have enjoyed the presentation and learned some new facts and about the SCAIME offer for Ethernet, industrial Ethernet. We are, of course, after this presentation, through the mails, remain at your disposal if you want to ask some more question or need some more information. Olivier and I will wish you all the best for the rest of the day, and maybe soon for another presentation.
Okay, bye-bye.
Bye.
Thank you very much.